In the same vein of thinking, we talk about precipitate reactions. Precipitate is um, no more complex than the resulting material that is visible of a chemical reaction, generally solid. Chemicals combine to form a change of state generally, and it's almost always a solid for chemical labs in general chemistry, but occasionally it's gas. Um, PPT is the symbol for it. Now, the example I'm giving here is potassium chromate. You'll notice the column 1 metal solutions very often are easily dissolved. And the other columns not so much. So we have potassium chromate with barium nitrate. If you paid attention earlier, the nitrates almost always stay in solution. So you have potassium chromate, barium nitrate. You're going to get a switch of partners in this reaction. So the barium will combine with the chromate to form barium chromate. And then you have potassium, which stays in solution, and nitrate, which stays in solution, forming barium nitrate or potassium nitrate. Now, obviously, we have a problem, Houston. The problem is that it doesn't balance. And as I've previously indicated, often a simple, easily produced number in front solves the problem. And thus, 2 potassium nitrates allows 2 potassiums and 2 nitrates on either side of the reaction. Metals often are used to provide these precipitate reactions. For some reason, we don't seem to have a. Let's see if I can get it to focus out here. If not, I'll change the spot. Try there. No, that's not doing it either. Necessary, I'll hold it up. Yep, I can do that. There we go. Metals are often used because they form nice PPTs or precipitates. Here we've got the classic, and nobody goes through general chemistry without doing this, at least once. You got silver nitrate plus potassium chloride. Again, silver is a metal that does not stay in solution unless, remember that little AQ means they're dissolved in water, unless, and that it is paired up with something that likes to stay in solution, and the nitrates love to stay in solution. So you got silver nitrate plus potassium chloride. Again, potassium wants to stay in solution, and chlorine likes to stay in solution unless mixed with a solid metal. So when you mix those together, you form a solid silver chloride, and the potassium stays in solution, and the nitrate stays in solution. And because there's equal amounts on both sides of the reaction, no numbers need to be put in front to balance it. So we say it is a balanced reaction. The precipitate, or PPT, is the silver chloride. Now, silver is used a lot, as is barium, for laboratory in general chemistry.